Good morning, everyone. My name is Janice Overbeck, and I'm pleased to be moderating this panel today. We're going to begin with each of us introducing ourselves, and that will be followed by a discussion that I will moderate, and then finally Q&A. But first, we are going to watch about a 2.5-minute clip from a TV series I'm working on. I produce documentaries on large-scale environmental and social issues, and right now I'm producing a TV series about the climate with Rob Riggle. And that was what got me connected to these amazing scientists and engineers up here. And so we're going to show you a little clip of that with Ralph here next to me, and then he will tell you a little bit more about himself. So we can go ahead and play that.
My first stop on this journey is San Diego's Scripps Institute of Oceanography. In 1958, Charles David Keeling established the first measurement of atmospheric carbon dioxide on record. And who better suited to show us how it's done than Dr. Keeling's son, Ralph? All right, Ralph, what are we holding there?
So these are glass flasks. These are a design that my father pioneered. Ones like these have been in use since the 1950s.
Surprisingly, I found out this method is still used today, and Ralph Keeling has been continuing the legacy of his father's work. So these are generally the exact same things?
Some of them are. Some of them are the exact same. And some of these have gone probably distances of more than from the Earth to the moon and back.
I wanted to get an idea of what's going on in our atmosphere and what these numbers mean. And can we really measure all this stuff accurately?
So all it is a glass sphere.
Okay.
And it's wrapped in tape for safety reasons because they're evacuated when they're sent out into the fields. That means there's nothing in them, no air, no nothing. And because it's evacuated, air will rush into it. You close it off, there's your sample. It's super simple.
The best things generally are.
So what you do is you hold your breath, walk into the wind, then you turn the knob.
Okay.
All right, so you hold your breath, hold it up, walk into the wind. That was brilliant. That was perfect.
Nailed it.
We got an air sample.
I like it. That's good. So now you take this back to the lab.
We take this back to the lab and we analyze it. We analyze it for carbon dioxide, we analyze it for isotopes, and we put a point on a graph. And that graph may go back 60-some years, right? So it's another point on the long journey up, unfortunately, of carbon dioxide.
All right, Ralph, how about you tell us a little bit more about what you do?
Okay. So yeah, I'm Ralph Keeling. That was me on that picture there. Happy to be here in Austin. They asked, how do we get anything done in San Diego with the beautiful weather and so forth? Well, the waves are not very good a lot of the time, so there's time to get work done. Yeah, I'm in the business of tracking changes in the atmosphere as my father started. My father created this curve, Keeling curve. Sadly, it's still going up and up and up. That's really why we're here today, is to talk about how to bend that curve. One of the things my father showed early on was that the buildup of CO2 in the atmosphere was actually slower than you expect based on the amount of fossil fuel we're burning every year, showing that some of the CO2 is being taken out. That's a good thing. But it was never quite clear exactly where it was going. And I was inspired by him to work on a parallel problem, which was tracking changes in atmospheric oxygen. There's a lot more oxygen in air than carbon dioxide. It was a tough measurement to track these little changes, but we've managed to do that. And for about 35 years now, we've been tracking the decrease in atmospheric oxygen. That's that upper panel there, oscillating, going downward, just as carbon dioxide, and the lower panel is going up. Why is oxygen going down? Well, simple, combustion. Right? You take oxygen out, you put CO2 in. So the burning of fossil fuels is driving oxygen downward. It's not an environmental concern because there's so much of it in the air. We'll run out of fossil fuels long before we've made a significant dent in the oxygen supply. But it's a super valuable diagnostic. Why? Because some of the sinks for CO2, namely the ocean sink, involves processes that don't produce oxygen, whereas other sinks, like uptake by a forest, involves photosynthesis and produces oxygen. So we can split the balance of the uptake, the sink processes, into categories that affect oxygen and don't, and therefore diagnose ocean versus land sinks. So maybe, okay. We've been able to track these sinks over time, and it's a super important bottom line for how we're doing on the problem. Now, as we push towards bending the curve, how are we going to do that? We have to cut emissions, and we also have to enhance sinks through some kind of additional sink processes. So through oxygen measurements and carbon dioxide measurements, we're in a position to establish a bottom line and show that we're actually not only bending the CO2 curve, but it's bending for the reasons we understand through our intervention. So I think I'll pass it on here to
Matthew.
Great. Thanks, Ralph. So I'm Matt Long. I'm the CEO, co-founder of a nonprofit research organization called Seaworthy. I have a background in computational oceanography, worked for a long time at the National Center for Atmospheric Research, building an Earth system model and applying that model to understand the impact of climate change on the carbon cycle and marine ecosystems. As Ralph said, we are faced with a problem right now, which is in order to mitigate climate change, we must cut emissions, but also begin the process of actively removing carbon dioxide from the atmosphere through carbon dioxide removal technology. You can advance to the next slide. This might sound like a broken record to you. I mean, I think most people have been exposed to this, and it's just this ongoing onslaught of doom and gloom, bad news. But one of the things I'd like to impress upon the audience today is that we're living in the pivotal decade. You can advance. Right now, there's a collection of activities going on predominantly in the private sector where startup companies are working to build the technology necessary to advance solutions to carbon dioxide removal. And we're living in the pivotal decade not for the deployment of carbon dioxide removal, but for building the technology and the social and scientific infrastructure necessary to manage this new industry. Next. One of the challenges in this space is that the type of intervention that is scalable for carbon dioxide removal are those that operate in open systems, where we introduce signals and those signals are entrained in this case, the flow of the ocean, and the signal of the intervention is at large in the environment. And that presents significant scientific challenges, as Ralph mentioned, to ensure that we know how the efficacy of these technologies and have clear understanding of their ecological safety. Can advance to the next slide. So what we are doing at Seaworthy is building the technology necessary to ensure the efficacy and environmental safety of ocean-based carbon dioxide removal technologies. We are intentionally incorporated as a nonprofit research organization, specifically because we believe the science is not resolved. So our goal is to actually build tools that comprise a framework for iterative refinement and can track the best available science as that science evolves in time. Next. So our theory of change is really predicated on the fact that we cannot sit as scientists in our armchairs and meticulously design the future, but rather have to engage with a whole collection of actors in the socioeconomic sphere, including the market, and build tools that companies can use to quantify their removals, provide those tools as effective standards for high integrity, trustworthy carbon market, and ultimately build the community of practice that is necessary to manage this industry as it grows to gigaton scale carbon removal over time, so as to have an impact on the climate change mitigation problem. Turn it over to you, Mina.
Okay. Hello, everyone. I'm Mina Zarabian, CEO and co-founder of Carbonova. My entrance into CO2 world was a bit of a serendipity. I was working on my PhD program in University of Calgary, Canada, building lithium-ion batteries, and it was all the time failing because our lab didn't have a clean room, and I had to work in the ambient atmosphere, and the material I was developing was reacting with CO2 for so long that I was failing into my PhD program, and I was up to quit my PhD. And that happened as a shift in my perspective, what this material can do. And I realized that the material I was working with was absorbing carbon dioxide, was capturing carbon dioxide, and was reacting with carbon dioxide and turning it into another material. That was the starting point for me to enter into the idea of carbon dioxide utilization. The circle that you see on the screen here, my team and I have been developing a technology that utilizes both greenhouse gases, carbon dioxide and methane, through a catalytic chemical process and convert that into solid carbon materials. And interestingly, as this reaction happens, it generates water, another important resource, and also energy as another important component of this reaction, which goes back to the reaction and makes it happen with less energy requirement. And this is a material that goes back again to the industries. As you see on the right side, the carbon material, the solid carbon materials, goes to a variety of application. Anything that you see around is black color has most likely have some solid carbon materials in it. The interior of the cars, the tires, the plastic that we use day to day. Most of that carbon comes from fossil fuels or from minerals, from the earth's minerals, and comes with very, very high CO2 footprint. For every ton of solid carbon materials that we use for our day-to-day product, there is about between 4 to 30 tons of CO2. This is way higher than a lot of other materials that we use, like steel, aluminum, cement. So the question for us was that, can we make solid carbon materials that goes to a variety of application just from the waste stream of carbon dioxide, because carbon dioxide contain solid carbon material, atomic carbon in it, and it can be used as a resource. So that's the story behind our technology.
The three of you are working on some amazing work. So I know from my research as a science reporter that we have about 52 billion tons of greenhouse gas emissions going into the atmosphere every year, and the goal is to get to net zero by 2050, 2060. So I'd like to ask you guys, how daunting is that task? Any of you can take it.
Maybe I start and then you can chime in. Carbon dioxide is known as a very lazy molecule. That's why most of the reactions in fossil fuel combustion goes toward formation of CO2, because CO2 has the lowest energy, enthalpy, that makes it very stable. It has two wings, so it doesn't want to really do anything. So breaking that molecule or capturing it on any surface requires a lot of energy. And that has been the challenge for capturing technologies. They do need to capture it on a surface and then release it for utilization. You do need to provide energy. That CO2 goes to another form of species. And energy, most of our energy today is coming from fossil fuels. That, again, generates CO2. So the board has had that challenge of the trade-off between how much energy do we put toward capturing, sequestering, and utilization of CO2 and the energy that this process requires, unless we use a lot of renewable energies. That has been one of the challenge.
I could just chime in there that there's basically 5 components that we need to think about in terms of fossil fuel reduction or reduction in greenhouse gas emissions. So the first is electricity production, where a transition to renewables is critical. Transportation infrastructure, similarly, electrification of transport is a major goal in reducing emissions there. Forestry and agriculture and industrial processes all involve a host of technological changes to reduce emissions. And then finally, energy production in residential and commercial buildings. One of the key things that is important to keep in mind in this space is that 52 gigatons is an enormous number relative to our capacity to remove carbon from the atmosphere at this point. And so it's really critical to think of the climate change problem as first a focus on reducing emissions, but because we know that the climate system is linearly sensitive to the amount of CO2 that has been released in cumulative amounts, the integral, since the beginning of the Industrial Revolution, it will be insufficient to simply reduce emissions to mitigate climate change, and we're as a society not proceeding fast enough down that path. So ultimately, there will be a requirement to actively remove CO2 from the atmosphere, and growing the scale of that removal is something that is a decadal scale, well, multi-decadal scale problem.
Probably the hardest thing that man's ever had to come together to solve. So I would like to know what it will take to actually see a bend in the Keeling curve.
Well, the curve has been going up, and it's been accelerating up as fossil fuel burning is at greater levels now than it ever has been. So the first thing that we would see, and I'm kind of hopeful that this might happen in the next decade or so, is if fossil fuel burning actually doesn't keep going up, but rather peaks, we'll see a change in the shape of the curve from accelerating upward to no longer accelerating upwards. It may even, it'll continue up because we're still emitting, but it'll start to bend over. So there'll already be a sense of hope through just stabilizing fossil fuel emissions and not getting up, not having them continually increase. Of course, that's not a milestone that puts us very far on a recovery path, but it's already a change in the shape of the curve that will be hopeful. What we really want to do is get emissions all the way to zero. At that point, the curve will not only peak, but will actually be starting down again.
What happens if emissions don't go down?
Well, you could, you're looking at me, so I don't want to jump in front of others. But there's a framing that basically says that the warming of the planet and the damage done is scales with cumulative emissions. Okay, so that's why net zero. Net zero is the point where you're no longer contributing additional loading to the atmosphere. It's the point at which you stop doing more harm. So that's kind of the milestone of if we wanted to get back to a climate like we had in the past, we'll have to do quite a lot of sequestration. But just getting to net zero is going to require some carbon capture because there will be likely continued use of fossil fuels for some industries that are hard to decarbonize.
And I have one more question for you right now, Ralph. I'm curious how the recent poll with U.S. funding in science and technology affects your lab directly.
Yeah, I mean, this is a big undercurrent of the moment, isn't it? So a couple points. Keeping measurements going long-term is not easy. It's against the grain of the science process where you discover new things and move on. I mean, we're kind of doing planetary medicine. So we're in a diagnosis mode. Why would you not keep monitoring the patient? So the patient is planet Earth or parts of the environment. So the community needs people to do that. It's very difficult to find support for that. There are a few agencies in the government that have a mission that embraces that. Most don't. And among those is NOAA, which is in the news right now. The program I run is not NOAA. So we're at the Scripps Institution of Oceanography, but it's up to me or my father or whoever to piece together different streams of funding to do that. We have got substantial in-kind support for NOAA over the years using their stations. Part of the oxygen measurements are funded by NOAA. But it's not been easy to keep these measurements going. There's sponsor fatigue. I mean, what do you do when someone says, okay, I did it enough, 10 years is enough, now you're on your own? That's happened more often than I'd like to say. So I think, especially in the context of the moment, it's going to take philanthropy to step in and help out here.
And that was actually my next question for Matthew. You run a nonprofit. Do you see a path where philanthropy can step in to keep everything going with things like Ralph's Lab?
Yeah, I think it's really important to just emphasize Ralph's point that there is a requirement for, as a society, us to keep our finger on the pulse of the planet, and long-term sustained observing is absolutely critical, in addition to other important large-scale research infrastructure. Um, I think the role of philanthropy in that space is predominantly catalytic. Most philanthropists do not have an appetite for long-term, supporting long-term sustained programs, and so the ability for an organization like ours to entrain philanthropic support is actually contingent upon framing the initiative as a finite term catalytic initiative that will ultimately transition into a more sustained funding model. So unfortunately, I don't see philanthropy as a recipe for the type of long-term sustained infrastructure investment that we need as a society, but it is of critical importance, perhaps in the present moment, to bridge to the future, and as a source of catalytic funding, emerging into new areas. It's extremely valuable and really important.
Okay, Mina, is there anything else you'd like to say about that? Consumers and companies stepping in. You run a company.
Well, it just came to my mind that um, the climate has a cost. What is happening, there is a cost. I was reading a report yesterday from Canada. For every dollar that we invest today, we are preventing $6 to be invested in a decade. So there is an accounting that happens for the cost that we pay for the economics for the global warming. But the challenge is how to bring that to today, to the perspective of people, and to the perspective of the government, so that these programs are actually generating economic values, and they are generating massive data information. We're living in the era of data, and it's quite surprising that why the data around what is happening to our climate is not as critical as the data of the day-to-day privacy of people that are being sold in the market. So I hope that the program of both these Seaborthy and also Keeling continues, because that's generating massive information for science to come up with the solutions. Like if you look at the solution that our company brought, or other companies with the economic value generation from CO2, all of that came from the angle of, let's do something else. Let's not use fossil fuels. Let's not look at CO2 just as a dumping waste. Let's find a way to other resources, other ways of generating value from CO2.
Okay, and I'm going to ask one last question. So if anybody has a question for us and wants to come to the mic, you can do so. So Ralph, when I first met you, you said that you would love to see in your lifetime the Keeling curve go down. And a few minutes ago, you talked about it leveling off, and it could do that pretty quickly. And I'm wondering if you think could we realistically in the world get there where you start to see it go down?
Well, this is really a question of how fast we can move to renewables. So it brings in that whole question. That's the biggest engine for reducing the rate of growth and turning the corner. So yeah, my understanding, it's not my specialty, but I drive an electric car and it works great, okay? It's not a Tesla. And
So if we saw like the greenhouse gas emissions went down 50% in like 5 years, how long would it take for the Keeling curve to go down? I mean, guesstimation.
well, it's going up every year because we keep emitting every year. So if we just stop emitting, it would start going down right away, because there was an excess in the air that would continue to be taken up from the ocean. So the CO2 curve will respond quickly to what we do as humans. So we have that control knob. We just have to start turning it.
So do we have to get to 0 for it to start going down?
It's a little complicated. There's sinks, as I said earlier, that are taking CO2 out even as while we're emitting. So the question I sometimes ask, well, what does it take to get the curve to flatline? So it's no longer going up. We have to cut emissions to a level where the additional emissions are offset by the natural sinks. And that's about cutting in half. So basically we have to cut in half to get it to flatline. But flatlining is not the end point because the world will continue to warm because there's residual warming in the pipeline. So if we want it stopped warming, we have to go beyond that point and get CO2 to start falling. So we have to cut more than 50%. And we have to do that fast to avoid the problem getting out of hand. So that's why all the urgency about trying to move to renewables quickly. There's an imperative to do that.
Well, it's been such an honor for me to get to know these folks up here really working on this massive issue. And I thank you for your time today and teaching all of us. So, yes, we will move to our first question.
Thank you very much for a great conversation. Question for the panel, maybe more specifically for Mina. How should we think about the technology in terms of carbon capture, in terms of where we are and how we should expect the kind of technology to develop over the next 5 to 10 years? I mean, we talk about this huge number of gigatons of carbon that we're putting into the atmosphere, and kind of how should we think about carbon capture as a technology to ameliorate some of that? Are we thinking like kind of 1 gigaton in 5 years or 20 in 5 years, or can you kind of give us a sense for? Neither do I. That's funny.
Maybe you could rephrase the question.
Yeah. So like in terms of Moore's law and all those kind of scientific concepts, can you give us a bit more of a sense of how we should think about the technology where it stands today and where we should see it in the near and medium term future? Thank you.
Yeah, there are two angles to that question on the capturing. One is CO2 capturing by itself, if it's captured, sequestered, and nothing happened with that CO2, is not generating economic value. So that's why a lot of governments initiatives are now turning down, because it sounds more as a cost. But if we look at that as a medication, then it's not a cost. It's a investment for the society to reduce the later cost coming into improving infrastructures, the cost for insurance, the cost for rebuilding, and that is coming for investment for the government. So it's quite interesting now to watch what is happening with the perspective of governments on the CO2 capturing, because in my perspective, CO2 capturing is not something that governments should look at it as profitable business for short term, but profitable business for their society, for their community. And that's the long-term investment that comes for CO2 capturing. But on the other angle, CO2 capturing can actually be economic when there is a value chain. So the way that in my company we looked at it was, how can we incentivize that CO2 capturing becomes economic, is where it turns into a value-added product. Right now, the only CO2 utilization that widely used as economic is enhanced oil recovery, which it's going down whole in the reservoirs and comes with more fossil fuels, more oils being recovered. That's economic because that results in generating more oil, but it's not in terms of the environment, in terms of contributing to net zero, it's not helping. But there are other solutions, there are other technologies that now is developing around creating value chain for CO2, being fuels, polymers, our solid carbon materials production. With those technologies, with the economic value for CO2, then there will be more motivation toward capturing CO2.
Yes, next question.
Very interesting panel, thank you. Lots of interesting stuff there. I'm a big renewable energy developer. I develop big renewable energy projects. So I look at that space across the whole world, and sadly what I can tell you is there is no way we're not going to be using lots of fossil fuels for a long time. I wish it were not true, but let's be realistic. That's the reality, unfortunately, which makes the panel and all the work that you're doing even more important, because we've really got to take carbon out of the atmosphere to compensate even for the continued use of fossil fuels. My question really is about the sinks for carbon. So you talked about, obviously, the fossil fuel emissions. You talked about green agriculture, or agriculture, trees, vegetation, taking in carbon dioxide. When I look at the future and I see the temperature increase that's going to happen because of what we've already emitted, and the kind of climate change effects of desertification and crop loss and problems with that, that's reducing one of the things that you see as a sink. It's going to be reducing, crops that we grow and because of drought, let's just say, across parts of the world. Is that effect taken into account in the models? And it seems to me it's a sort of it's a positive reinforcement of further increasing carbon dioxide in the atmosphere, because we're going to be losing that sink and so on. So do you see a snowball effect happening where, frankly, we've really got to turn into a sort of military society, taking carbon out of the atmosphere, with all our energy focused on doing that?
Sounds like a good question for Ralph.
Yeah, yeah, great. So the quick answer is yes. I guess then what was the question, right? So yes, the calculations that project forward do allow for the evolution of the sinks, and in principle they allow for the feedbacks that are kind of in a predictable realm, like the fact that the oceans might warm up a little bit and the circulation might change a little bit. Now there's uncertainty in that. But I should point out that there's a sink for carbon in the ocean that's natural. There's a sink on land. The ocean sink has been behaving a little bit more predictably. It's driven by rather simpler processes. And there's no reasonable scenario that has that stalling or saturating anytime soon. The ocean is vast. It continues to mix. There's a capacity for absorbing. It's a big sponge. The sponge is still there. The land sink's a different story. It's not as well understood. It's based on mysterious thing called photosynthesis and life and all that stuff. So lots of things could go wrong. That's carbon that's sitting on the landscape, could burn up. So we have benefited over the last 50 years or more from uptake of CO2 on land. The ecologists in the 1970s and 80s didn't believe it was happening, and it took the atmospheric and oceanographers to say, hey, it must be going somewhere, it's going into your realm. And after a while they embraced it and said, yeah, it is going in. But that just shows you the state of the science. So what's happening on land, there's a sort of uncertainty and concern about that. From my perspective, how do I look at this problem? The problem is bad enough that we don't need to get bent out of shape about catastrophic scenarios of the land plants burning up to get motivated to do something about it. So as a scientist, I say the problem is already bad enough with the sinks acting in the way we expect, that we know we have to work hard to reduce emissions. And there is some chance that it could be even worse than that. But from my perspective, looking at the system, I don't see that happening yet. And so I don't lose sleep over that. It's not to say it couldn't happen, but our eyes on the planet, it looks like it's behaving more predictably from the standpoint of the sinks.
And you were talking about the mixed energy future. So from working on this TV series, yes, I've definitely seen that we'll have a very mixed energy future over the next 30 to 50 years. But we visited the Lawrence Livermore facility that had the big fusion breakthrough in December of 2022. I was recently in Boston at Commonwealth, the project funded by MIT. And it's interesting because with nuclear fusion, it's always been the big joke, oh, with fusion's 15 years out, it's 15 years out. But now it's really happening. It's going to be happening in the 2030s. And, it's just really, really exciting because you've got something the size of a table that you can start implementing around the world to really make a big dent in those emissions. So that's something positive and optimistic there. Yes, please go ahead.
Thanks. You answered some of my questions already, so I've morphed my question a little bit. First, I do a lot of work on adaptation, and I would say that it's hard to get the economics accepted on damage avoided, even with short-term gains in adaptation, let alone a century ahead in terms of a government investing. So I'm a little skeptical on that. The utilization is another matter. But my main question had to do with the amount of money and attention that's given to carbon capture, utilization, storage, and so forth, mostly at the behest of the oil, gas, and coal industries versus some of these other. Is that the best use of our funding for more mechanical means of carbon capture? And I guess one last question, do you lose sleep over acidification?
Sorry, what was it last?
Do you lose any sleep over ocean acidification, given you said you didn't lose sleep over
Well, I'm an insomniac, so it's hard to measure my sleep loss, but but I've been talking a lot. Maybe Matt.
Well, Ralph, do you want to speak briefly about acidification, and then maybe Mina could answer what he was talking
Yeah,
about?
just what is it? I mean, the ocean, the CO2 is a mild acid, so you dissolve it in seawater, you change the pH and the ion balance of the ocean, and that has detrimental impacts, particularly on organisms that precipitate shells made out of carbonate. And that has an effect on the food chain and the balance of life in the ocean. It has some effect on coral reefs, although they're probably more damaged by warming than by that, at least from my understanding. So it's on the list of things that carbon dioxide does to the planet beyond just causing warming, and it's concerning. But to the
And then, so the next part, talking about funding in the carbon capture versus other technologies to help reduce down the 52. Do either one of you want to talk about that? And I'm happy to talk about it a little bit as well.
I can just say a few words briefly. That the first thing is to point out the distinction between carbon capture and carbon removal. Carbon capture, entails eliminating an emission, whereas removal is actually a negative emission, and those two things are fundamentally distinct. There may be a role for carbon capture as sort of a bridging technology or an important thing to sustain certain energy supplies over time, but ultimately we need both a complete cessation of emissions and active removal.
One thing I have found from my research from working on this TV series is that once the world kind of discovered how interconnected we are from COVID, there's been a massive amount of funding into from private and public sectors into all of the different technologies from agriculture, transportation, you name it, to mitigate these greenhouse gas emissions. And there's some really exciting stuff that's in the infancy, going to be commercialized here in the coming years. So I guess, yeah, if we can use renewables to do carbon capture, that'd be great. But it is something they've been trying to figure out for 30, 40, 50 years, mostly funded from the fossil fuel guys to keep going. And that's obviously not the end all be all or the solution. So, yes.
Hi, my name is Sade. I specialize in supply chain and operations, so I know there's a great deal of work from government and large organizations to reduce emissions in the air, but it feels very intimidating for the average consumer. Are there any advice that you can give to the average consumer on what they can be doing to make a difference in their everyday life?
That's a good question. Matthew, you want to go? You want to take a stab?
I guess my perspective is that this problem cannot be solved by personal behavior. So my advice is that they vote and demand action at the collective scale from our leadership.
You can make small differences by what you purchase and what you choose to do and what you do for enjoyment and so forth. You can make a small difference. That's not going to add up to making the change we need, but it is something you can do that's in the right direction.
And with that, with making the purchases that you do, having conversations with your friends about what you've learned. So I think a good example of that is plastics, right? Plastics are made from fossil fuels, and they're not degradable. They're turning into microplastics. There's endocrine disrupting chemicals in them, and just trying to use less of that and have those conversations, and is a start. But definitely the voting is the big ticket there.
Thank you.
Hi. I have a question about scale. Mina, in your technology, how much, like, what is sort of the maximum impact that that kind of approach to carbon utilization can have? And then, Matt, for you, alkalinity enhancement, what does that look like at scale? What does that act, how much material are we talking about moving? What kinds of materials are we talking about moving? And what does it look like in practice?
I start. Um, for our technology, for the amount of carbon, solid carbon that the world requires is about 20 million tons per year. So the world uses 20 million tons of carbon that is either generated from fossil fuels or from minerals. If we look at that in terms of the CO2, it's still far from the amount of CO2 that we require to remove. If we add up other chemicals that can be produced, like fuels, plastic, still we are far. We're orders of magnitude far from the amount of CO2 that requires for removal. And that is the reason, back to earlier question, that we need a diverse range of technologies, from capturing and sequestration geologically to convert into value-added product, to renewable energy solutions. And depending on jurisdictions, some of these solutions may not work. We have clients from Korea that they came to us as a problem that we want to reduce the CO2 coming up from one of our plants that is already 95% coming up from the flue gas. It's a chemical reaction generating 95. It doesn't even need capturing technologies. But what can we do with that CO2? We want to get to net zero emission. We have to transport it all the way to Australia, and that costs a lot of money and not generating any value, and contribute to more CO2 emissions by transporting it to Australia. So if we look at diversity of solutions, some works for some locations. If we look at the whole value chain or life cycle of the products that we generate, we are still in a puzzle that we need to have different solutions, different toolkits to be able to complete that perspective of where does each solution make sense. And if we lose this opportunity of having a lot of horses in the race, then we will not be able to catch up with the recovery or even getting to the flat curve.
Great. Scale is a great question. So just for a point of reference, each year we emit about 40 gigatons of CO2. Only about half of that remains in the atmosphere. The rest is absorbed in roughly equal proportion by the ocean and the terrestrial biosphere. So 10 gigatons into the ocean, 10 gigatons into the land. The ocean comprises 72% of the planet's surface areas, right? So the entire ocean sink is about 10 gigatons, and that's mediated by the natural processes of the overturning circulation, and the absorption of CO2 and seawater is mediated by chemistry that is quite well understood. The question about ocean alkalinity enhancement is a good one. Ocean alkalinity enhancement is something that we understand the underpinning of the science quite well. Carbonate chemistry is something that is very well understood. And so we have, I think, a high level of confidence that if we were able to increase the alkalinity of the surface ocean over a sufficiently large area, we could induce enhanced uptake of CO2 from the atmosphere. The question is, how do we mobilize the alkalinity? And unfortunately, the ratio at which you induce enhanced carbon uptake to the amount of alkalinity you supply is roughly 1-to-1. So the implication is that you need to mobilize order gigaton scale minerals to enhance or to induce a gigaton scale sink. And so I think that's really the fundamental challenge there, is that there's a whole suite of engineering challenges related to enhancing the alkalinity of the surface ocean over a sufficiently large area to scale. And what does that look like in the future? I don't think we really know. There's multiple approaches. People are exploring electrochemical methods, so basically, using electrodialysis to split seawater into an acid-base stream and then returning the base stream to the surface ocean as a flux of alkalinity. That's a process that can work based on renewable energy and induce uptake locally. And then applying crushed rocks to coastal areas, or perhaps distributing those crushed rock material actually out in the open ocean. As another point of reference, global shipping is order 14 gigatons, right? So that's the total flow of material that we're moving around by ships. And so something on the order of a gigaton, I think, is what we're expecting kind of a scaled ocean alkalinity enhancement industry to look like.
That's very interesting, Matthew. And we have a few more minutes, so I actually wanted to put you on the spot and see each of you, really, but we can start with you, Matthew, since you were just speaking. Can you tell us a little bit more about what you're working on right now with your company and what the next few years look like?
Sure. So one of the things that we've recognized as critical is that direct observation is insufficient to provide an indication of the efficacy of these ocean-based carbon dioxide removal technologies. Rather, we need a combination of direct measurements and numerical models. And so what we're doing at Seaworthy is building a collection of tools based on cutting-edge oceanographic modeling systems. So these are large-scale models that we run on supercomputers that predict the flow in the ocean and then represent the processes that mediate the transfer of carbon from between different pools in the ocean. We are making those tools available to a collection of startup companies. So these are privately funded companies that are building technology to remove carbon from the atmosphere. And we're providing those tools and operating as a nonprofit explicitly so as to provide line of sight towards credible approaches to quantification, with the objective of unlocking additional private capital to flow into the development of such companies and technological innovation. So our goal really is to provide sort of a pivot around which we can induce an inflection point in the growth of this carbon dioxide removal industry, basically building in a credible scientific framework for quantification so that investors and buyers of carbon dioxide removal on the carbon market can feel confident and trusted, and trust that the claimed removals correspond to actual removals.
That's amazing because it's just interesting that there's so many different technology or different ideas of how you can actually go in and make the ocean absorb more. I think that's fascinating. Mina, what about you? Tell us what you're working on a little bit more.
Well, as we are developing, commercializing the technology, we are now scaling up into our first of a kind commercial unit. We have a pilot unit up and running in Calgary, Canada, that is generating product, and we're working with customers to showcase how they can use more of these materials within their value chain. We have a very fantastic project with one of the largest health and beauty companies that they target to use less than 20% virgin plastic within their packaging application. So we are helping them to reduce the amount of plastic that it goes to their packaging by improving the properties of the plastic, and also being able to bring more recycled plastic to their applications by matching up the properties of recycled plastic back to the virgin plastic. So when customer pick that from the shelf, they don't even recognize that it's recycled plastic. We are building the first commercial unit right beside a power plant that provides the energy of the city of Calgary. They do have the CO2 capturing in place, but the CO2 captures as just a test trial, and then after that it's being vented to the atmosphere. So we do have that opportunity to just plug into the CO2 capturing in place and show that how it can be turned into a valuable product.
That's awesome. So it's interesting. So you were telling me a little bit yesterday. So the recycled plastic doesn't have the look or the uses, the properties as much as the original virgin plastic. But when you add in the carbon, it's actually stronger and better in many uses.
Yeah.
Very interesting. And then you're also, removing carbon. So it's a double whammy. All right, Ralph, tell us a little bit more about what you're working on right now.
Okay, obviously I'm keeping long-term measurements going, but my career started with developing technology for measuring really tiny changes in oxygen, precision measurements of the atmosphere. That research program continues with measurements of other species in the air, and my group is also working on to make more precise measurements of carbon species in seawater. And I'm working with groups in collaboration to use these data to infer sinks and understand how the planet is changing. There's all sorts of signals of change that emerge from these data. Often we are the place you first see something, the big picture. Something show up at the big picture before they show up at the small scale. Like the carbon sink, we discovered it from the air, and then people scrambled around to try to figure out where it was going on land. Another thing I've done in the last few years is to launch a foundation called the Keeling Curve Foundation. The imperative for this was recognizing that my father's legacy was big enough. He's a big enough person in the history of science that an organization was needed to look after that. And the foundation also has taken on the role of championing people like him or organizations like him who make a transformative understanding of how we look at the world by making long-term repeated observations, something we absolutely need. He is the role model for doing that and making a difference. And it's a tough row to hoe. He showed that it was worth doing, and there are lots of people like him out there trying to keep long-term measurements going, not being sure where the next 5 years or 3 years of funding is going to come like he did. And they also need recognizing like he got.
It's really such an incredible story because not only is the Keeling curve named after your father, but he was really one of the first few climate scientists, right, to dedicate his life to this and what he's uncovered. And then you've continued. I think it's just amazing. And we obviously really need to know this information. So thank you. And looks like we have one final question. Go ahead.
Thank you. I wanted to ask all of you, how do we not lose this battle without turning the adversaries of climate change into allies?
How do we not win this battle by turning the adversaries of climate change into allies? Well, does anybody want to take that?
Well, that's almost a statement which we need to think about. So, yeah, I think. It's important to just stay with your game and stick with it, and eventually people come to you. And so not every, for example, every side of the aisle needs to know what's happening to the environment over time. It affects everybody. And so at some point you can make that clear. So people go through their life with blinders on, but you get too torn. But yeah, maybe you want to elaborate.
I'm an architect, and I focus on a net zero built environment in Washington, D.C.
Yeah.
And with the geopolitical environment, it just seems, I don't know if we can afford to lose 4 years.
Yeah.
I think to piggyback on what he said, we all have a role to play. And in my role in this, I feel, is I like to put out content on very large scale environmental and social issues. And right now the TV series I'm working on is very unique because we have actor and comedian Rob Riggle, who's 23-year Marine vet, and he's a everyday guy, and he kind of comes in as a complete layman, and we travel all around the world. We even go to Antarctica with the World Wildlife Fund, and he's really trying to understand what is happening to our planet and what can we do to make it better. And so we learn all about these clean tech innovations that have really taken off since COVID. And I think we do it in a way, or we're trying, and the entire purpose behind this TV series is to do it in a way to get people to engage and watch instead of having 100 million Americans turn it off and not care or not want to hear about it, because this is a very unique country where that happens. My husband's German, and everybody there is very concerned about climate. So, as it seems, mostly. So I think just what he said, we all keep going forward, and then the straw's breaking the camel's back on everybody getting a clear picture that we all should be concerned. That's my perspective.
Just add a couple thoughts. One is that I think it's increasingly people's lives are increasingly being impacted. The cost of natural disasters in this country is order $150 billion a year right now, and that is projecting onto people's livelihoods. It's projecting onto people's ability to get homeowners insurance, to sustain a mortgage. And so I think connecting the dots between these threads that are present right now and growing in our society is really important for our collective consciousness and be able to project that into the space that we and the demands that we make of our elected leadership. The other thing that I think is important to note is that there is movement in parts of the private sector, and we cannot trust all corporations, but and that there's a prevalence of greenwashing and sort of sanitizing public relations, but there's also real change and real movements. I think the commitment by Microsoft, for example, to go to, as a company, net zero by 2030, and then to remove from the atmosphere the cumulative emissions since the inception of the company by 2050 is exemplary. And I think that there are other instances where we can look to corporate leadership and ensure that if we're sort of forward thinking in the sense of empowering private sector actors with the appropriate science so as to ensure that action is actually culminating in real change with respect to the climate. There's a lot of opportunity in developing technology and solutions that doesn't necessarily require government, though ultimately this is a collective problem, and we need collective leadership on all the things that are necessary to have at the table: sustained observations, large-scale infrastructure, demands in the context of policy changes that incentivize the right sorts of behavior and the right investments into renewable energies. So it's a huge problem, but every sector of the society has a role to play. And I think that's really important. And just the fact that it is manifest now in people's lives is really important to recognize.
I want to add just a little bit to it. I was a couple of weeks ago in Decarb Connect event happening in Houston. A lot of corporate chemical businesses, Dow Chemical, BASF, attending. And a lot of those corporations are still waiting to see what is the behavior from the customer changing so that they adjust their ESG goals for the next years. So I think the way that we communicate, all the behavioral changes that are happening through social media, through films, through the demand that it still shows from customer sustainability in the next year or so is very critical. And that's going to define for corporations that what will be their goals. And they are the one that can play a role in changing the perspective of the governments when they see the demand is still continuing from the customers. So we had this question earlier, what can we do? The data that you use in social media, because a lot of survey is happening through the data that we consume day to day. Movies, films, we watch, music that we listen, people that we follow, all of that matters in terms of reading how the behavior of the society going to be in the next couple of years.
That's a great point. Yes, real quick.
I'll make it real quick. First of all, thank you all. And I want to direct this to you, Ralph. Boosting your point about the Keeling Foundation, working in the field, I recognize the incredible importance of having long-term measurements in a world where scientific results get questioned by various political actors. So I'm imploring everyone here, turn over the sofa cushions and make sure that you support the incredible work that is done by you and the Scripps, people at Scripps, and your father as well. Thank you very much.
Absolutely.
That was great. Thank you. Well, thank you everyone for coming to our session today. And if you have any other questions for us, we'll be outside. Thank you.